Welcome to episode 5, the final video of the Midnight Developer Workshop series. Over the last 4 episodes, we have built up the full developer toolkit, the CLI wallet for deploying from the terminal, the compact playground for prototyping a smart contract, Web3 Fast for AI-powered scaffolding, and the Explorer for verifying what lands on-chain. Today, we bring it all together with the final piece, wallets. Lace and 1AM are the two browsers extension wallets for Midnight, and the DApp Connector API is how your code talks to them. By the end of this hour, you will know how to detect wallets, connect to them, query balance, and submit transactions. Let's go. Let's start with the fundamental question. Why should you, as a developer, care deeply about wallets? It's easy to think of wallets as an end-user concern, just a place to hold tokens. But that's only half of the picture. Wallets are the user's gateway into your DApp. They handle three critical things. First, user authentication. No passwords, no accounts, just a cryptographic identity the user controls. Second, transaction signing. Only the wallet can authorize on-chain actions. Your DApp requests, the wallet approves. Third, and this is Midnight specific, zero knowledge proof generation. Every private transaction requires a zero knowledge proof, and the wallet is where that happens. Understanding wallets architecture makes you a dramatically better Midnight developer. When you know how proofs are generated, where keys live, and how the connector protocol works, you design better the apps. Let's meet the wallets. Lace is built by IOG, the same organization behind Cardano and Midnight. It's a Chrome extension using Manifest version 3. It manages 9 tokens with both shielded and unshielded balances. It is fully non-custodial. Your keys never leave the browser. Lace comes from the Cardano ecosystem, which means it inherits a proven cryptographic stack. HD wallets, BIP39 mnemonics, BIP44 derivations, all battle tested. You can download it from lace.io. If you use the CLI wallet from episode 1, remember, they are compatible now since version 2.5. Same mnemonic, same derivations, same addresses. You can import your CLI wallet into Lace and vice versa. Now, meet 1AM. This one was built from scratch, specifically for Midnight. That headline feature, it runs zero knowledge proof entirely in the browser using WebAssembly. Your private data never leaves the browser tab. No proof server, no network calls during proving, maximum privacy. It also has AutoGas sponsorship. Users never need Dust tokens to pay fees. The Relay network handles that, and it ships with a dedicated developer SDK for programmatic wallet interactions. Privacy is a default with 1AM. Shielded transactions are on by default, not an opt-in toggle. You can get it from 1am.xyz. Here's the side-by-side. Lace comes from the Cardano ecosystem. It delegates zero knowledge proof to a proof server. Users manage and pay Dust, and it exposes the wallet via window.midnight.mn lace. Shielding is a toggle you turn on. 1AM is Midnight native. Proofs are generated in browser via WASM. Gas is auto-sponsor, so users never see Dust. It ships a developer SDK. Shielding is the default, and it registers via window.midnight using the CAI IP standard. The good news, both connect through the same DApp. Connector API, the center box. That's what makes your life easy. You write your DApp code once, and it works with either wallet or both. The DApp Connector API follows CAIP 372. That's a chain-agnostic improvement proposals. It's a standard protocol for how the apps communicate with wallets. You write your DApp code once, and it works with Lace, 1am, or any feature Midnight wallet that implements the standard. And here's where episode 1 connects. Remember Midnight Serve, the CLA wallet, the DApp connector? It implements the exact same API. So your DApp can talk to the CLI during development, and Lace or 1am in production. Zero code changes. From a developer perspective, here's the life cycle you will implement in every Midnight DApp. 5 steps. Step 1. Detect available wallets. Check window.midnight for providers. Step 2. Connect via the DApp connector. Call connect with a network ID. The user approve in a pop-up. Step 3. Request transactions. Build your transaction payload. Submit it through the connector API. Step 4. Handle zero-knowledge proofs. The wallet generates them, either in browser with 1am or server-side with Lace. Step 5. Manage sessions. Handle disconnections, network changes, error gracefully. This pattern is universal. It doesn't matter which wallet the user has. Same flow every time. Let's zoom out and see how all 5 episodes fit together. This diagram is the entire Midnight developer ecosystem. Episode 1, the CLI wallet, your terminal gateway. Deploy contracts, manage wallets, run a local network. Episode 2, compact playground. Write and test smart contracts in the browser. Episode 3, Web3 fast. AI-generated contracts scaffolding in seconds. Episode 4, Explorers and Indexers. Verify what's actually on-chain. And now, Episode 5, Wallets. This is the DApp integration layer. This is where real users connect to everything you have built with the other 4 tools. Lace and 1am are the front door to your DApp. Without wallets, everything else is just developer tooling. With wallets, you have a complete product. Here's the plan for the rest of this session. 3 parts. First, we will deep dive into Lace architecture, the connector API, night tokens management, how proof delegation works. Then we will do the same for 1am. In-browser zero-knowledge proof, AutoGas sponsorship, the developer SDK. Second, we will cover the DApp connector standard itself, CAIP 372, wallet discovery, connection flow, transaction submission, and integration patterns. Third, hands-on. We will install both wallets, write wallet detection code, build a mini DApp from scratch, submit a transaction, and test the CLI fallback from episode 1. Let's get into it. All right, let's get into the architecture. We will start with Lace, then 1am, then the DApp connector standard that ties them together. Lace is a Chrome extension built on Manifest version 3. Under the hood, it inherits Cardano HD wallet structure, BIP32 for hierarchical deterministic derivation, BIP44 for a standardized path. This is the same key management architecture we talked about in episode 1 with the CLI wallet. Transaction signing happens locally in the extension. Your private keys never leave the browser. But here's the key architectural difference from 1am. Lace delegates zero-knowledge proof generation to a proof server. The private witness data goes to the server. The server generates the proof, and the proof comes back. This is faster, but means you are trusting a server with your private inputs. Lace exposes the connected API interface, the same one that Midnight Surf implements from episode 1. This is why your DApp code is wallet agnostic from day 1. Lace managed 9 tokens in 2 modes. Unshielded balance are visible on chain. Standard transfers anyone can see. Shielded balances are protected by zero-knowledge proof. Amounts are hidden on chain. Users need DAS tokens for gas fees. Remember from episode 1, DAS generates over time after you register? With Lace, users have to manage that themselves. This is the real user experience friction point, and it's one of the reasons 1AM took a different approach. Under the hood, Lace maintains a dual state model, public state plus encrypted private data. It abstracts the complexity so users see a clean, balanced screen. But as a developer, you should know this is what's happening when your DApp interacts with the wallet. Here's the connected API interface. Fourth method you need to know. Get unshielded balances. Returns the user's public balance. Get shielded addresses. Returns their private addresses. Submit transactions. Takes a transaction object and send it through the wallet for signing and submission. And get proving provider returns the proving provider. This is how your DApp requests zero-knowledge proof. Here's the critical point. This is the exact same interface the CLI implements via Midnight Surf. Same method signatures, same return types. Write your DApp against this interface and it works with Lace, 1AM, or the CLI. We set this up in episode 1. Now you see why. Now, let's look at 1AM architecture, because it takes a fundamentally different approach. Compact circuits are compiled to WebAssembly modules. When 1AM needs a proof, it loads the WASM module right in the browser tab, feeds in the private witness data, and runs the entire computation in the browser sandbox. The proof never leaves. No server ever sees your private inputs. This is the maximum privacy architecture. It's censorship resistant too. No server can refuse to generate your proof. The trade-off is performance. In-browser proof take longer than server-side delegations, roughly 5 to 30 seconds depending on circuit complexity. But for users who prioritize privacy, that's a trade-off worth making. As a developer, you don't need to worry about this difference in your code. The connected API handles it transparently. Let's dig deeper into how in-browser zero-knowledge proof actually work, because this is a really impressive engineering. Step 1. Compact contracts get compiled down to WebAssembly modules. This happens at build time, the same compilation step you would do in the compact playground from episode 2. Step 2. When the user triggers a transaction, 1AM loads the WASM module into a browser worker thread. Step 3. Private witness data. The inputs that should stay secret are fed directly into the browser memory. Step 4. The WASM runtime generates the proof. Step 5. Only the resulting proof goes on-chain. The private inputs are garbage collected. No network calls, no server trusts. The proof generation takes 5 to 30 seconds depending on circuit complexity, and WASM optimizations are improving this with every release. Proof stay local equals maximum privacy. 1AM ships with a dedicated developer SDK. This is a major difference from Lace. 3 lines of code to connect, query a balance, and transfer tokens. Import from 1am SDK, call 1am.connect, and you've got a wallet handle. From there, get balance and transfer work exactly how you would expect. Clean, minimal API. The SDK also supports headless mode for testing and CI/CD automation. So you can write integration tests that exercise wallet interactions without a browser window. Lace doesn't offer this. With Lace, you would use the CLI's Midnight Surf for the same purpose. But with 1am, you get it built into the wallet itself. Gas sponsorship might be 1am's killer feature from a user experience perspective. Users never need DAS tokens. Remember the DAS warm-up period from episode 1? How you had to wait 5 minutes on a fresh network for DAS to generate? And remember error 138, balance check overspend? With 1am, your users never see any of that. The relay network pays fees on the user's behalf. As a developer, this is completely transparent. Your code doesn't change, but your user experience is dramatically better. No insufficient gas errors, no onboarding frictions, no dust faucet dance. Compare that to Lace where users must acquire and manage dust themselves. For consumer-facing DApps, this difference is massive. Now, let's talk about the standard that makes all of this interoperable. CAIP 372. CAIP stands for Chain Agnostic Improvement Proposal. Number 372 defines how wallets inject themselves into web pages. The protocol uses JSON RPC for communication, request response format, just like what Midnight Surf uses over WebSockets. When a wallet extension loads, it adds a provider to Windows Midnight. Each wallet registers under its own namespace key. Lace uses MN Lace, 1am uses its own key. The standard ensures that any CAIP 372 compliant wallet works with any CAIP 372 compliant DApp. Write once, connect to everything. The wallet discovery flow is very simple. 4 steps, 4 lines of code. Step 1. Check if Windows Midnight exists. If it does, at least one wallet extension is installed. Step 2. Call object keys Windows Midnight to detect all installed providers. You might get back mnlace or mnlace 1am if both are installed. Step 3. Show a wallet picker user interface so the users can choose. Step 4. The user selects a wallet and you proceed to connection. That's it. No wallet specific code, no conditional logic. The CAIP standard means discovery is universal. Once the user picks a wallet, here's the full connection flow in 6 steps. Step 1. Check Windows Midnight exists. Step 2. Call connect with the network ID, like prepro. Step 3. The user sees a pop-up in the wallet extension and approves the connection. Step 4. You get back a connected API handle. Step 5. Use that handle to query state and balances. Step 6. Submit transactions. From nothing to a connected wallet in 4 lines of code. The user approval pop-up is the only thing that takes human time. Everything else is instant. We will build this exact flow in the hands-on section. Here's the transaction submission pipeline. 5 steps happening behind the scenes when your DApp sends a transaction. Step 1. Build the transaction. Recipient, amount, token type. Step 2. The wallet signs it locally. Private key never leaves the extension. Step 3. Zero knowledge proof generation. This is where Lace and 1am diverge. Lace delegates to a proof server. 1am run it in the browser. Step 4. The signed transaction plus proof are broadcast to a midnight node. Step 5. Wait for the transaction to be included in a block and finality reach. Your DApp code is the same regardless of which wallet handles step 3. The connected API abstracts the proof generation entirely. There are 3 integration patterns you should know about. First, direct integration. You connect to one specific wallet, maybe just Lace or just 1AM. Simplest approach, good for prototyping. Second, multi-wallet. You detect all installed wallets. Show a picker, let the user choose. This is the best pattern for production DApps. Support everything. Let the user decide. Third, CLI fallback. During development, use Midnight Serve from episode 1 instead of a browser extension. No extension to install, no pop-up to click, same API. This is what makes the Midnight developer experience smooth. You develop against the CLI and deploy against browser wallets with zero code changes. For development and testing, you don't need a browser extension at all. Just run Midnight Serve network preview approve all, and your DApp connects the same way. The WebSocket server on port 9932 exposes the exact same connected API. Your code works identically whether it's talking to Lace, 1AM, or the CLI. The approve all flag or approve every transactions. Perfect for automated tests, obviously not for production. This is the power of building on a standard interface. In episode 1, we set up Midnight Serve as a development tool. In episode 2, we use it to test compact contracts. In episode 3, Web3 Fast connected through it. And now, in episode 5, you see it's the same connected API that Lace and 1AM implement. Full circle. Everything connects. All right, enough theory. Let's build something. Time to build. We're going to install wallets, write connector code, build a mini DApp, and test the full pipeline. If you are following along, open Chrome and your code editor. Before we start, make sure you have 4 things. Chrome browser, required for both wallet extensions. The Lace extension installed from the Chrome Web Store. Preprod network configured in your wallet settings. And optionally, the 1AM extension from 1am.xyz if you want to compare both wallets side by side. Okay, let's start with the first demo, which is about installing Lace. In this slide, you can see what we are about to do. Okay, let's switch to the browser. Okay, let's continue with the second demo, which is about installing 1AM wallet. In this slide, you can see what we are about to do. Okay, let's switch to the browser. Okay, let's continue with our final demo, the starter template. Rather than wire everything up by hand, we will use a complete reference DApp called the Edda Labs Midnight Starter Template. It's open source, integrated with all the wallets, CLI, Lace, and 1AM out of the box. Pull it up and you will see four fork spaces. Counter contract is the compact smart contract plus its compiled zero knowledge keys. Counter CLI is a small TypeScript CLI for deploying and interacting from the terminal, the same pattern we used in episode 1. Front-end Vite React is a React app you see in the live demo, with all the wallets wiring inside. In this example, we're going to interact with a counter, and we are going to increment it using the CLI wallet, the Lace wallet, and the 1AM wallet. Okay, let's switch to the terminal. Let's step back and look at what we have built across this entire series. Episode 1, Midnight Wallet CLI, your terminal gateway, multi-wallet management, local network, DApp Connector, MCP for AI agents. This is your development foundation. Episode 2, Compact Playground, browser-based contract compiler. Write compact smart contracts. Test them. Iterate fast. No local setup needed. Episode 3, Web3 Fast, AI powered contract generation. Describe what you want in natural language. Get a working contract in seconds, from idea to code, instantly. Episode 4, Explorers and Indexers. Chain visibility. Verify transaction. Inspect contract states. Debug what's actually on chain. Trust but verify. Episode 5, Wallets. Lace and 1AM, the user-facing layer. This is where your DApp meets real users. Detect wallets, connect, transact, all through a standard API. Together, these 5 tools are the complete Midnight developer toolkit. You can go from zero to deploy user-facing DApp with privacy-preserving transaction using just the tools we have covered in this series. Official docs are at Docs Midnight Network, and all the community tools are listed in Midnight Awesome DApps. 5 episodes, 5 tools, one complete developer ecosystem. You started with the terminal wallet and ended with the browser-based DApp integration. Along the way, you learned compact smart contracts, AI-powered scaffolding, on-chain verification, and now wallet connectivity. You have everything you need: a CLI for building and testing, a playground for prototyping, an AI tool for generating contracts, an explorer for verifying, and 2 wallets for connecting users. The full stack. Privacy-preserving applications are the future of Web3. Midnight gives you the tools to build them, and now you know how to use every single one of those tools. It is still coming 2 videos, episode 6 and episode 7. These 2 episodes are a little bit different from the ones that we have done so far. In episode 6 of the Midnight Developer Workshop series, we zoom out from tools and talk about a bigger vision, the machine-to-machine economy, in which every drone, rover, actuator, and sensor has a sovereign cryptographic identity and negotiates with each other through zero-knowledge proof. And in episode 7, we talk about the 2 communities behind Midnight, Nightforce and Elite. Go build something on Midnight, something that matters, something that protects people's data while still being useful and verifiable. The technology is ready. The tools are ready. Now it's your turn. Thanks for watching the complete series. If it was helpful, share it with another developer who's curious about privacy on the blockchain. Drop your questions in the comments. And most importantly, go build. See you on chain.